In note 6.6, examples 2 and 3, we're going to evaluate inverse trig functions by hand. In order to do that, I want to highlight the intervals for the outputs for each of the 3 inverse trig functions that we're studying. Sine inverse, cosine inverse, and tangent inverse. So for sine inverse x, I'm going to make a little sketch here. It looks like this. So sine inverse of x, I'll go through these points. The x values, the inputs, have to be between -1 and 1, and the outputs are going to be between -π/2 and π/2, which is the right half of the unit circle. Right, so output values are going to be on the right half of the unit circle. And that's what I really focus on and try to remember. For cosine inverse of x, the graph of the function looks like this, and it's going through 1, 0, 0, π/2, and -1 pi. And what I really like you to focus on is where the output values are. So the output values are going to be on the top half of the unit circle. So the outputs are going to be between 0 and pi inclusive. The inputs are going to be between -1 and 1. I'm going to make a little sketch of tangent inverse of x, just so you can remember what it looks like. Tangent inverse of x looks like that. And it's bounded between π/2 and -π/2. So the outputs, that's what I really like you to focus on. The outputs for tangent inverse of x are between -π/2 and π/2 exclusive, not including the endpoints. And the inputs for tangent can be all real numbers, so -∞ to infinity. So having an image of these 3 graphs, kind of these sketches at the top, will help you when evaluating inverse trig functions. So before we dive in and evaluate a whole bunch of them, I want to translate into English, so it's kind of in quotes, what the problem is asking us to find. So if we're asked to evaluate sine inverse of -1, that's telling us to find the angle. It's only going to be one value. The angle in radians in the interval. It's a specific interval, and you have to say it in this interval. In the interval from -π/2 to π/2, whose sine is -1. And so when I'm doing these problems, I would make a little unit circle and then remember that for sine inverse, the outputs are going to be on the right half of the unit circle between -π/2 and π/2. And now we have to find the point in this interval that has a sine of -1, and that point is going to be at -π/2. Please note that you cannot name this as 3π/2. Even though that's a coterminal angle, the interval for these outputs is between -π/2 and π/2. So if you write 3π/2, that is incorrect. Okay, our cosine of -1. So that's asking us to find the angle in radians in the interval 0 to pi, whose cosine is -1. So if we sketch a little unit circle, and remember that for inverse cosine, those angles are going to be on the top half of the unit circle. And then we want a cosine value of -1, and so that value is going to be at pi. So that's our answer here, because this order pair is -1, 0. Okay, for tangent inverse, when we're asked to evaluate that, so in this one in particular, tangent inverse of -1, it means find the angle in radians in the interval, in the open interval, we should say, negative pi over 2 to pi over 2, whose tangent is -1. Okay, so I'm going to sketch a unit circle. I'm going to remind myself that I need angles on the right half of the unit circle, excluding the endpoints. They have to be named between negative pi over 2 and pi over 2, no coterminal angles. And I want a tangent of -1. So tangent of -1 occurs at this point because the x value is rad 2 and the y value is rad 2 over 2, the y value is negative rad 2 over 2. So this angle is negative pi over 4, not 7 pi over 4. Okay, even though those are both coterminal angles, this must be named in the interval from negative pi over 2 to pi over 2. Okay, now we're going to go ahead and evaluate some inverse trig functions. So sine inverse of rad 3 over 2. So we're going to find this one. So I'm going to make my unit circle. I need to find the angle on the right half of the unit circle, including the endpoints, whose sine is rad 3 over 2. That means the y value is rad 3 over 2. So the point that I need to pick is here. This angle is pi over 3. This coordinate is 1/2 rad 3 over 2. So the answer here is pi over 3. Okay, arc sine of negative rad 2 over 2. Arc sine is the same thing as sine inverse. So we need to find the value on the right half of the unit circle whose sine is negative rad 2 over 2. So that's going to be a reference angle of pi over 4. So this point has a coordinate of rad 2 over 2, negative rad 2 over 2. And now we need to name it negative pi over 4. Okay, not 7 pi over 4. All right, so I'll just summarize. This is the angle in negative pi over 2 to pi over 2, whose sine is negative rad 2 over 2. For letter C, we're trying to find an angle in the interval 0 to pi, whose cosine is 1/2. So I'm going to sketch a little unit circle. Remind myself that I need to be on the top half. I need to name the angle between 0 and pi. And the point with a cosine of 1/2 is up here. This is pi over 3. And the coordinate here is 1/2 rad 3 over 2. So this answer is pi over 3. Okay, letter D is asking us to find an angle in the interval from 0 to pi inclusive, whose cosine is 2. So thinking about this, is there an angle whose cosine is 2? And this answer is no solution, right? So this is no solution because there is no angle whose cosine is 2, right? Cosine, the parent function, has a range of -1 to 1. So if we're outside that interval from -1 to 1, we're not going to be able to find an angle with that given cosine value. Okay, letter E is looking at arctangent. So we're asked to find arctangent of 1, and that means to find the angle in the interval negative pi over 2 to pi over 2. It's an open interval whose tangent is 1, positive 1. So I'm going to draw my unit circle, and remember that I need to be on the right half. So I'm looking for angles between negative pi over 2 and pi over 2. That's the interval in which I need to name them. Tangent's going to be 1 when sine and cosine have the same value, and that's going to occur at pi over 4. where they're both, sine and cosine are both rad 2 over 2. So this answer is pi over 4. Okay, tangent inverse of 0, that is asking us to find an angle, or the angle in the interval negative pi over 2 to pi over 2, whose tangent is 0. So I'm going to sketch my little unit circle. Remember that I have to be on the right half of the unit circle between negative pi over 2 and pi over 2. Tangent is the y value over the x value, so I want the y value to be 0. That occurs at an angle of 0 because that coordinate is 1, 0. So tangent inverse of 0 is 0. And the last problem, sine inverse of pi over 2. So here we're trying to find an angle, or the angle in the interval negative pi over 2 to pi over 2 inclusive, whose sine is pi over 2. Now this is a bit of a trick question. Pi over 2 is about 1.57. So we need to find an angle whose sine is 1.57, but the largest value for sine, the maximum value, is 1. So this is, there's no value, it's an empty set, because there is no angle for which sine equals 1.57, right? Sine is bounded between negative 1 and 1. So I'm going to say, I'll write that down. Sine x has a range of negative 1 to 1. So this is outside the possible values for inputs for sine inverse.